welcome. In this lesson, we are beginning our study of ratios and proportions. Ratios can feel very symbolic once we start writing them with numbers, but the idea behind ratios is something students often understand informally first. They might think about recipes, paint colors, juice mixes, trail mix, lemonade, or how much of one ingredient goes with another. So before we define the word ratio, let's begin with the situation. Let's imagine we have two containers. Each container starts with the same mixture: 1 cup of red punch and 3 cups of lemon lime soda. The first container is left alone. We'll call this one mixture A. So mixture A has 1 cup of red punch plus 3 cups of lemon lime soda. Now, in the second container, somebody adds 2 cups of red punch and 2 cups of lemon lime soda. We'll call this one mixture B. Let's carefully figure out what's in mixture B. It started with 1 cup of red punch and 3 cups of lemon lime soda. We then added 2 cups of red punch and 2 cups of lemon lime soda. So now mixture B has 3 cups of red punch, 5 cups of lemon lime soda. So here's our important question. Do you think mixture A and mixture B will taste the same and have the same color? Why or why not? Let's pause and think about that. Mixture A has 1 cup of red punch and 3 cups of soda. Mixture B has 3 cups of red punch and 5 cups of soda. Mixture B has more of both ingredients, but that does not automatically mean it tastes the same. This is a big idea. When we compare mixtures, we are not just asking, does it have more red punch or does it have more soda? We are asking how the amounts compare to each other. Mixture A has 1 cup of red punch for every 3 cups of soda. Mixture B has 3 cups of red punch and 5 cups of soda. Mixture B has more red punch, but it does not have 3 times as much soda. If mixture B were keeping the same flavor mixture as mixture A, then tripling the red punch from 1 cup to 3 cups would require tripling the soda from 3 cups to 9 cups. But mixture B only has 5 cups of soda. So mixture B will be more red punchy than mixture A. It will probably taste stronger, sweeter, or fruitier, and it may look redder. Now let's think about this as future teachers. Suppose a student has not studied ratios yet. What ideas might that student have? A student might say that mixture B has more of both things, so it'll taste the same. That's a very understandable idea. They may be focusing on the fact that both ingredients increased. Another student might say mixture B has more red punch, so it will taste more like red punch. That student is noticing one important part of the comparison, but they may not yet be comparing red punch to soda. Another student might say that mixture B has more total cups, so it'll be stronger. That student is thinking about quantity, but not necessarily concentration. Another student might say that mixture A has 1 red and 3 soda, so if we add more, we need to add 1 red and 3 soda again. That student is beginning to reason proportionally, even if they do not yet know the word ratio. As teachers, we want to listen carefully for these ideas. Students' informal reasoning is not something to skip over. It is the foundation for formal ratio thinking. You are doing great. Ratio reasoning starts with common sense. How much of one thing goes with how much of another?